Okay, ladies and gentlemen, let's try something. Okay, so you guys showed me last class you basically understand the projectile motion stuff. Now we're going to do it at an angle. So, you kick a football, you kick a soccer ball, you fire a cannon, shoot a rubber band gun, it's all the same. Everything goes up, and everything comes down. Now, there's a few things to note here, and if you can note it, it will make your calculations in your life a lot simpler. Now, first thing, whatever your V initial is, your V final, VV, will be equal to and opposite your V initial. So if you're going up at 10 meters a second, you're becoming down at 10 meters a second. That's one thing to note. The second thing to note here I should number this. Number 2, Vx is constant. So whatever the velocity is, once you finish kicking it or pushing it or punching it or hitting it, the velocity in the x direction doesn't change because there's no acceleration in the x direction. Once the ball leaves your foot, you're not pushing it any farther or any harder. It's only gravity working on it. Now, next thing to note, this angle going up is equal to this angle going down. The same angle. Okay? Now, what's new here for you guys, right here, let me rewrite this. V initial. We have Vx, angle theta. This is Vy initial right here. So this is the new stuff. We can split this up into a right angle triangle. Vectors. Now we're going to do several examples of that in a few minutes. I just want you to realize that now. So far, so good? All right. Now, right here at the top is something else. At dy max, you have Vx and Vy is 0. It's not going up, it's not going down.
That's y equal to
Vy is 0, yes. So if you're throwing something up, the velocity at the top is 0, just for a moment. The x and the y-axis only, not Vx. Vy is 0. Now, the last thing is a cheating shortcut. Now, somewhere along the way, I showed you this formula. Velocity final minus velocity initial over time equals acceleration. We don't use it because we normally rewrite it. Now, how we rewrite it, we do a little substitution. Or acceleration is minus 2v initial times time. Now that's a neat little shortcut if you can remember it. It's not on your formula sheet. If you want to take a moment and write it on your formula sheet, you can.
the bottom one?
Yes. Now, I was going to say, what's acceleration? What's acceleration? We're on planet Earth. What's acceleration? Negative 9.81. So we're figuring another way to calculate gravity. Woohoo! Who cares? It's 9.81. Now, what we often do is rewrite this equation to solve for time. So if you know the initial velocity, you can figure out the time the object will be in the air. So this is a better equation to know. Because gravity doesn't change, and usually you can measure V initial fairly easily. Okay? So, a whole bunch of nice theory stuff. Let's do a couple questions. You kick a soccer ball at 20 degrees with an initial velocity of 15 meters a second. I want to know time. How long is that ball in the air? So, note I did not give you a paragraph to go with this, but you've all shown me you can copy out a paragraph, but I don't want to waste the next 5 minutes doing that. So, I kick the ball at 15 meters a second at an angle of 20 degrees. What do I know? Yes, Gabe?
Velocity, gravity, and the angle.
Yes. Now, as we did last class, table of values, I don't care. Now, what do we know here? What have I told you?
Well, gravity's big enough.
Yes. Now, eventually, I'm going to give you the question, the astronaut Aliyah is on planet Mars. She drops whatever. You will get one of those where you have to calculate G. Until then, since we're on Earth, G is 9.81. What else have I told you? No. Velocity initial is 15. Good. Now, I need, or what you guys can do, is break this up into Vx and Vy initial, sorry. Oh, you know that's 20 degrees. Now, can you guys split that up into Vx and Vy? Well, you did a couple days ago for me before the weekend. Do you remember how to do it? Some of you going yes, and some of you are looking at me. Okay. Sydney, choose a side.
The purple one.
Purple. All right. So this would be the opposite. And what side did I give you? Hypotenuse, even though I forgot to point out it's a right angle triangle. So you got hypotenuse and opposite. So you go to, oh, wait a minute, this is a right angle triangle. I don't even need the hard sine law and cosine law. All I need is what? If you've got both sides. Oh. You don't have sine on your. Oh, yes, you do. They just didn't put it in the picture. My bad. Right there. So the provincial exam data sheet doesn't give you the triangle. Now, you all took Math 10 with me. You all know you write out the formula. Not suggestion, not hint. Write it out. Then you plug the numbers in. Sine of 20 degrees is Vy initial over 15. So, who can split that up for me and do the math?
I'm splitting, just not bad.
It's recorded for posterity. I'm going to send that link to your mother. All right, as for the rest of you, pull out your calculator.
5.13.
Sorry?
5.13.
5.13?
Yes.
Okay. More than normal? Over here. Come here. Come here. Oh, God. All right. I also have a spare calculator behind the kettle, or behind the coffee pot. All right. Now, Sydney said 5.1. Was that Sydney or Angel that said 5.13? Sydney. All right. So one of you guys, tell me what Vx is. Now, what formula would you use to solve for Vx? You can use cos. That would probably be the easier. Now, as I said, try not to use that 5.13 unless you have to, because there's always a chance you made a boo-boo. That's just life. You know the 15, you know the 20, so use that. And yes, cos. Yes. But that once again, you'd be using the 5.13. Now, I think that's the correct answer. It's just sometimes you make a math boo-boo. And it's better if you don't use that just in case, but whatever. Adjacent. So solve it for me and tell me what Vx is. But I don't have a calculator. You're the one that's supposed to have to.
I think your thing died.
Sorry? Good. Well, I didn't think it's supposed to do. Anyway, let's try over here. Maybe it just likes Kelly. I don't know. No. Everybody smile. See who gets fixated upon this time. I can understand it being jealous of your hair, but still, that's getting annoying.
I think it's jealous of you, like.
Come here, boy. Come here. Oh, God. All right. All right. While we're all admiring Bill Gates and wondering how the hell he screwed this one up, somebody tell me what Vx is, please. 14.1. Now, this is the only real difference between horizontal projectile and projectile and angle. We've got V initial in the Y. Now, is there anything else I can put down here? There's a couple of things. Shh. Stop and think for a moment. What else can I put down? What else do I know? Gravity and? What else did I circle here? What was the first thing I talked about? Yes. Final velocity is equal to an opposite V initial. So if V initial is plus 5.13, this is going to be minus 5.13.
So what happens if it's 0?
Sorry?
If VI is 0, does that mean VI?
No. That's when you're going, VI, when you're going driving the car off the car park.
Oh.
This is we're going at an angle. Now, what's the one last thing we can figure out? Or I've told you. Well, sorry, I haven't told you, but you should be able to figure out. Yes? True, that's a formula, but what's one other thing you can figure out? Come on, you played soccer or rugby or football. What distance? Okay, you don't know horizontal distance, but what can I say about the vertical distance? In this instance, how far is the ball going up? What's the displacement of the ball? Vertically. It goes up and it comes down to 0. And anytime you can put a 0 in there and cancel stuff out in your formula is a good thing to do. Now, do we need all this information to solve for time? No. But it gives us choices. Because I like this displacement 0 thing. It makes my life easier. Now, what formula can I use to solve for time now that I've got V initial, V final, acceleration, and displacement? All of them except for the last one. So, eeny, meeny, miny, mo. Which looks to be the least bad? Velocity final equals velocity initial plus AT. Now, I should say this, since we're in the Y, I should talk about the Y direction and acceleration in the Y, just for the heck of it. Because someone will always put Vx in there thinking about Vy. It happens. As I say, where I come from, poop. Anyway, so can you guys plug in the numbers and solve for me? Go for it. Race you. Where is it? On your? At home?
Is it not possible to get this test back to you?
If you quite leave me alone, yes. When you're working on your... Come on. Come here. I don't know. That's really like Eli. Or possibly Gabe. Anyway. So, come on, guys. What answer are you getting here? Show me. 1.04 seconds. That's what you got? Yeah. You're saying something? I can't hear you. What did you get?
Well, I can't hear me either.
Okay. What answer did you get? Got to find out. All right. So. Several people said 1.04 seconds. I tend to agree with them. Should I agree with them?
Yep.
Thank you.
Where'd you get negative 4.68?
What she said. All right. So, as I was saying, the big difference here is V initial is not 0. All right. Nathan shoots a three-pointer from the half court. Nothing but net. Hey, shh. Good for him. Now, more importantly, you're sitting there with your iPad thing filming this for a physics experiment because you know Mr. Sutton's going to be asking you dumb questions about this. You note dy maximum is 20 feet. 20 meters, sorry. Feet, meters, the other feet. All right. I want to know the time it took to get halfway, to get to that high point right there. Now, shh. All right? Now, careful. To solve this, you have to be able to listen to me and figure out what I told you. And look at the picture. So, what am I asking for? The time to get to the high point here. I'm calling it time half. It should be time high point, because I don't know how high the net is. So, I want this time to reach the max height. So, when we go to our table of values, what have we got? Oh, it is Vy initially. Now, look at the question carefully and help me fill in the table. So, Angel, what's one thing we know? Kelly? Gravity, yes. Acceleration? Yes. Now, actually, I was asking Angel, but Trevor, you can volunteer and be a gentleman and help her out. Yes. When you're at the top here, your velocity in the y direction is 0. Thank you. That makes life much easier. Now, what else do we know?
Dy is 20 meters.
Yes, plus 20 meters. No, we're looking for the time to get halfway, or to the height here. As I said, I should call this, I don't want to call it for H max, time height maximum, but I will, because this is not completely symmetrical. I don't know how high Nathan is versus the net. We could, but I'm not wasting my time doing that. Now, is there anything else we know? Do we know Vx? Dx? Time? Vy initial? No. What have I asked you to solve for? Time. Can we solve for time with V final acceleration displacement? We do not have V initial, so what formula do we have to use? Displacement V final t minus 1/2 at squared. Now, yes, we can solve that. Plug in the numbers and solve, please. Oh, sorry. Okay. Now, Kelly, are you going to copy some of this out? Okay. Check. It's fixated on somebody over there. Yes, Gabe?
So the VY final and the V and the T in the beginning of all of them, it's always 0, you know?
Sorry?
What's that? You're always, when you're doing the beginning of some
Okay.
equation for a kid,
Now,
0.
two things here. At the beginning, and when you're coming down at the same height, velocity final is equal to an opposite velocity initial. So if I kick this up at 15 meters a second, it's going to come down at 15 meters a second. Okay? That's one thing you have to remember. The other thing I pointed out, right at the top here, you only have Vx. Vy is 0. Because gravity's pulling it down. It's like throwing anything up. Something you can throw. At the top, velocity is positive. It's 0. Then it starts falling, so velocity becomes negative. But for a minute there, for a moment right at the top, Vy is 0. Okay? So the two versions of this question I tend to ask, right here at the end, V final is equal to an opposite V initial, or at the high point, Vy is 0. Because if you know that, that makes your calculations a poop load easier. Come here. Come here.
Is definitely Eli.
Eli or Gabe, I haven't figured it out yet. This way. Come on. Come on. Come on. I have treats. Come here. God. Anyway, where was I? All right.
Now you want a dog.
Sorry?
Now you want a robotic dog.
Woohoo! At least I don't have to clean up after it much. All right. Yeah, I don't have to take it out for walks when it's raining. All right. Now, so as I was saying, Gabe, beginning, the end when the height is 0, or in the middle height maximum. That's the two versions of the question I asked the most. Now this one here, we went V final. We're at the top here, so V final and the y is 0. Now if I wanted to, I can work backwards and go dx, vx, and time. I just haven't. That's something else. Now plug in the numbers in here. What do you guys get for time?
2.01.
Show thumbs who got 2.01. All right. Who didn't get 2.01?
I got 2.2.
2.2.
That's wrong.
Probably. Hang on. Now, no. We all know who to respect and fear, but let's just double check. Displacement, sorry, I gave you displacement, is 20 meters. 0 minus 1/2 minus 9.81 meters per second squared times t squared. $985. So 20 divided by 4.985, isn't it? What do I get? 5 something? 4 point. Help me out here.
4.08.
So time is the square root of that? 2.01. What she said. Now, you made a math boo-boo. We all make boo-boos. It's learning from them or hiding them. At this point, it's learning from them. Okay? So, Gabe, that's the other version at the end. Now, I'm going to throw one more at you, then I'm going to give you the evil one. Then I'll be quiet. Can I go on, Gabe? All right. So I want to see everybody working on this. Yep. Okay, now, shh. It's not that funny. Mr. Sutton's potato gun fires a tater at 8 meters a second at 50 degrees.
50 degrees from the ground?
Yep. It's kind of scary, so I mount it on the ground and back away a little bit. So, yes, unlike watermelons which grow in trees. Shh. Guys? So this, I promise, shush. I promise you'll see stuff like this on the test and quiz. And this happens to be a 3-part question. So note the 3 parts of the question. I shouldn't sit there. So, 3 questions. How long is the potato in the air? How high does it go? And what's the range? So what do we do? Right. First thing, copy out the question. Second thing, solve a physical problem. Read the question carefully, underline or highlight the information. Third thing, next thing, I'm sorry, is?
Right, what you know?
Right, what you know. Actually, isn't it draw a picture? Yeah, it's a little glossy there. All right, so we got to draw a picture. Now, as I said before, do not spend a lot of time. Okay, 8 meters a second at 50 degrees. That's a crummy 50 degrees. Let me fix that. It's going to come down over here. Now, okay, so for this question, what do I know and what can I put in? So you're consistent as gravity. Yes, assuming we're on Earth with you humans. All right, so somebody else, JJ, give me some information. Something else you can get from what I've told you, fill in the data table.
It goes 8 meters.
Well, the velocity is 8 meters a second. That's not Vx, not Vy. Yes?
dy is 0.
Yes, it goes up and comes down. This is 0. Is there any other easy number we can come up with?
Would byf be 0 as well?
Nope. If we're going up and coming down, it's going to be equal to and opposite whatever Vy initial is.
Which is 8 meters per second.
Careful. It's 8 meters per second at 50 degrees.
Oh.
Now we got to split it up. 8 meters a second, 50 degrees, Vx, Vy initial. So, ladies and gentlemen, a little bit more trig, or vectors. Can you split that up into Vx and Vy initial for me? Sorry? It does. It was 8.00. No. That's going to say that's easy enough to mistake to make. That's why I changed it to just 8. Because otherwise, yeah. We're dealing 800 meters a second. We're dealing with, yes, shooting down airplanes or possibly small satellites. But either way, it's far too much work and dealing with the government, and no, don't want to do that. Way too much paperwork. So, what do you do? Split it up. Kyle, I'm going to ask you what Vx is. And JJ, no, who hasn't volunteered recently? Shayna, you can tell me what Vy initial is. Yes. Okay. Who agrees with her? 2, 3, 4. Okay. Are you agreeing with her because she works hard, smart, and usually gets it right? Or are you agreeing with her because you've done it and you agree with the number?
A little bit of both.
Bit of both. Actually, that's good, but still, you should check the number. This would be the opposite. So this is cos of theta. Oh, cos, the other sign. Thank you. So 6.13 is reasonable. Is she right? All right. So what else can I put on the data table? Yes. Yeah. Oh, I also want Vx. Notice this is a multi-part question, which means you're probably going to have to fill in the whole freaking table anyway. So let's do it. What's Vx? Kyle asked. Hang on. No, I asked Kyle.
Oh, 5.145.
Okay, do we believe him?
Yes.
All right. Pythagoras or cosine law?
Pythagoras.
Okay. Distance in the x, tx. Okay, I asked for, the first question was time. All right, we got Vy initial, we got Vy final, acceleration, displacement. What's the easiest formula to find time? Plug the numbers in, please. What is the top one, by the way? Okay, so you guys plug these numbers in and tell me what you're getting. 1.25. Thank you. What you got?
There, 12.26. I'm just kind of doing it in my head right now.
Oh, okay. Well, as long as you can do it and show me you can do it, I don't mind you doing it in your head. Come here. Come here, boy. Come here. Come on. This way. Come on. God. I don't want to know. See me a break. Break. I want to get through this first. All right. Now. Oh, poop. Ow. Space. Now, sorry, who was getting? What time did you guys get?
1.25.
Okay. Now, can I show you a cheating shortcut?
Yep.
All right. And she's speaking for the class?
Yep. Oh, yeah.
All right. Now, part B is evil. Why is part B evil?
It's just, oh, we just did it over.
You have to do it all over again to find height maximum.
Which is VF0.
Yes. So let's skip that because the range is another way of saying dx. So as long as we get all the numbers here, what's dx?
5.145.
Well, we know this is, oh, I'm sorry, I forgot to say 1.25 seconds. So 5.14 meters a second and 1.25 seconds is how many meters? Multiple. Velocity is displacement over time. Displacement is velocity times time. 6.4 something meters. All right. Not the best soccer kick, but still. Or not the best potato gun, but it was 800 meters a second I'd be shooting down airplanes. Anyway. Now, you all agree with that? And let's not shoot down airplanes. There's too much paperwork. Now, the question, how high does it go? Oh, you Wiener Schnitzel. Now, how high does it go? That's a different question. As Ethan said, it's a different data table. What changes? And?
Your displacement is unknown now.
Yes. And hang on. It's not dx and it's not time. What?
It would be half.
Yes. So what's half the time?
0.75.
No. 0.75 is 1.25 divided in half. 0.625. Now, can I figure out distance in the x? Do I need it?
Yeah.
Well, I'm going distance in the y. I've got Vy initial, Vy final, acceleration, time, and I'm asking for distance in the y. What's the easiest formula to use? Hint, if I can get V final in there, it's 0, I got much less calculations.
Then use the top one.
I don't mind the bottom one.
Well, they all work. Actually, I shouldn't say that. The bottom one, the top one I can't use because it does not have distance at all. Any of the other four I can use.
But you don't want. Oh, you want to find distance.
Yes. So you've got a choice. Distance equals, distance equals, distance equals. Now, offhand, Vy final is 0. So if I go to this black one, number 4, distance is 0 minus 1/2 at squared, which is the simplest calculation, I think. But they all work, and this is a big bucket. Oh, wait a minute. Velocity final squared equals 0. Sorry, 0 equals velocity initial.
That's why I looked at you now.
Well, it doesn't really matter. They're all the same. They will give you the same answer. I'm just going what's easiest. Surprise me. You guys tell me what you think is easiest and solve it. Now, as I said, I think displacement equals V final oh, sorry, you're right. 1/2 minus 1/2. Sorry. Minus minus. So what do we got?
I got 1.9.
1.91 meters seconds. Meters, the other seconds. All right. So I'm going to stop there. Now I want to make certain everybody has a copy of the homework. Now, we rushed. There is one more example that I want to do. Plus, you still have to do that lab, so I will give you some time in class tomorrow to work on this. But please, start it tonight. Who doesn't have a copy here? Okay. Who does not have a copy?
I do not.
All right. Give me the marble back. I don't trust you guys with marbles.
Do we have to do lab?
Well, if you haven't got time today, we'll do it tomorrow. Come here, boy. Come here.
Come into the conversation.
Okay, I've got an extra. That's why I have an extra copy. All right.
Ethan, do you want to?
Come here, boy.
What are you doing?
All right. So, there we go. So, okay, guys, as I said, I haven't got time to do the evil example, so I will give you, I don't know, maybe the first half of class tomorrow to finish this and finish the lab. So start this tonight, please. You should be able to do the first 6 or 7, at least the first 6. You don't have a copy? Oh, marble back, please. All right, thank you.